Now, we're doing the same thing as yesterday, just a little more complicated. And a couple little tricks in there. Now, this is really, really awesome advice. In fact, I just got this question about 3 minutes ago, and I get this question all the time. I got this question probably 15 times yesterday. So, can I show you what this means? This says you can cancel factors, but never terms. Now, factors are things that are multiplying to each other. Terms are adding and subtracting together. Okay? Terms are like words. Do you know how you know the difference between each word? There's a space. You know how to tell the difference between each term? There's a plus or minus sign, not a times sign. Okay? 3 times 4 is actually one term. A times B is one term. Okay? Because the times sign is the same thing as putting them beside each other. So, what am I trying to say here? So, what if you had A plus B over A? And you cancel those. Is that allowed? No. You can never cancel terms. Now, so this is a big no. Well, cancel factors. Like, what does that mean? Okay, if it was like this. A plus AB over A. Well, guess what? I can factor something out. So this would be A times 1 plus B all over A. Now do you see that A is a factor? Why? Because it's multiplying to the thing beside it. If it's multiplying to the thing beside it, I can cancel. Okay, so this is a yes. Now, that little tidbit of information, that's a sweet thing to have on a study sheet. Because what's the final exam for? Like, come on, we all hate them. If you love final exams, you are weird, okay? They're stressful. They're like, oh, I'm going to get everything screwed up. I got to know all this stuff, right? What are they for? They're actually for the one main purpose of, can you synthesize a bunch of stuff at one time? Or do you get it mixed up? Do you have things confused? Have you forgotten things? Okay? That's what a final exam is for. Because wouldn't life be awesome if it was take an exam, done? Done forever. Next one, take an exam, done. Look how low stress this class would be. People would still work as hard because it's done. I still want to get good marks on that exam. But wouldn't it be nice if you didn't write final exams? When many, many years ago when I taught junior high at this one school, they had actually a incentive program that if you got over 80 on the course, you didn't have to write the final exam. Pretty sweet incentive, eh? You know, the kids that got 75 average, you should have seen them in grade 10 finals. It was no problem. They were able to write final exams. The top students were freaking out in grade 10. They hadn't written a final exam in their life, some of them. So that's why they canceled it, because the kids that were getting over 80 were getting killed in grade 10. They had never written a final. Like, how do you study for a final exam? So the kids that were like getting under 80 averages in grade 7, 8, 9, yeah, they always had to write the final exam. Ha, 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 look at them in the gym. I'm out here, right, playing in the sunshine. They were getting good at final exams. They had to study. They had to learn how to do them in grade 7. Maybe grade 7 they screwed them up really bad and they failed them all, whatever. Then grade 8, you know. So 3 years of, so it's a skill. So why do I make you do these study sheets? Believe me, it is not a make-work project. I promise you, promise you, promise you. At the end, it will save you hours of time. Because when you pull that thing out, you're going to see this rule right here, and you're going to go, oh yeah, and then it's back, right? Because this rule will be tested, okay? Are you making that mistake still? Okay, now let's go through and just do a few examples. So we're just going to, for example one, we're just going to do B. Okay, now B is probably the most challenging one out of these, but not above what we've done already, because we have done all of this. This is pure review. It's just when you look at B, B is like two questions. Like in last unit, they just said factor this. Do it, done. The next one would say factor this, do it, done. Well, this is factor this divided by factor this. So I have to do them in kind of two separate questions going on. So my blue, I'm going to keep in blue so you can kind of understand that. Now, in blue here, I'm going to think, well, what two things do I have to add to get me 5 and multiply to get me -6? Okay. Anytime you want to yell it out. No. No. 6 and -1. The positive has to win, right? Okay. So 2x squared plus 6x minus 1x minus 3. Okay? So the blue is done, aka the top, the numerator. Let's do the red. I need what two things add to give me 1, what two things multiply to give me -2. 2 and -1. Okay? So I got 2x squared plus 2x minus 1x minus 1. Okay, and the top, I have this set of brackets. I'm going to take out a 2x, leaving me with x plus 3. The other one, I'm going to take out a -1, leaving me with x plus 3. Okay, doing the red, I'm going to take out a 2x, not just a 2, but a 2x, and I'm going to have x plus 1. The other one will take out a -1, leaving me with x plus 1. Okay, now we're getting there. You just see all the opportunities to make mistakes. But remember, if it's a test, you're going to get one of these maybe, so you can just, put every blue one in your calculator, see if you get the same graph. If at one point you're not getting the right graph as the rest, that's where you made your mistake. Go find it. Okay? So I have on the top x plus 3 over, and then 2x minus 1 over, and we're going to take the x plus 1 out, and leave me with 2x minus 1. Now, the fun, right? Bye. Okay? That leaves me with x plus 3 over x plus 1. Now, remember for rational equations, you're going to get in the habit of this, right? Because every single question you have to do it. You can't just leave it that way. You have to always say the restrictions. So we want to go through the whole question and look where the restrictions are. So x, we know, cannot equal -1 and 1/2. Where would 0 be bad? 0 works for us. Yeah, but then this is minus this all, right? So this would still exist. Yeah, so you kind of want to get to the factored stage to do this. Okay, does that make sense? So again, I really haven't done anything new. Finding the restrictions was yesterday, and simplifying polynomials was the entire last unit. Okay, now example 2A with C's in it, This is the most important concept of this lesson. Okay? It is something that you have to know to do to be able to do it. A nice little thing on a study sheet, so when you look at it in 2 months, you'll understand it and remember it. Okay? Just think about the trig unit. Remember the trig unit? All the things that were in there? Read the one page over, you will get the entire trig unit back. That one page you did. Okay? Some people are going, did we do trig this year? I thought that was last year. No, and that was only a couple months ago. Okay? So, when you got those 8 pages and you read them over, you will be back in the game with all the units. Now, what's going on here? Like C minus 4 or 4 minus C. Now, can I cancel the C's? Why not? Because one's negative. They are terms right now. You cannot cancel terms. You can only cancel factors. But here's the cool thing. I'll leave the top the same. Doesn't matter. But if I can get the bottom looking like the top, I get to kill them. I get to cancel them. So if I took, and just because I can, right? If I took a negative 1 out and made this negative 4 plus C. Now, have I changed the question at all? Take my negative and multiply it back in. That'd still be 4 minus C. But what has happened here is, do you see, maybe some people don't even see this, these two are now identical? They look identical? Okay, so what this does, and I'll even, this is the same thing as C minus 4 over 1 and C minus 4. Okay, that's just negative 4 plus C. I've just changed spots with them. And all of a sudden, oops, why did I put a 1 out there? It should be a negative. All of a sudden, these now cancel, and I'm left with negative 1. Now, negative 1 is the answer. But it did have something in the bottom. It did have something in the numerator, denominator, I mean. So we have to talk about it, that C cannot equal what? 4. Okay? This is a huge concept. It'll get you out of a lot of jams. And in fact, there will be questions on the quiz, there'll be questions on the unit exam that you'll never get to the final solution unless you know that trick. Okay? Because students, once they see it once, most now know, because all the questions are very, very creatively, selectively chosen to be able to make sure, like, do you know this process? Do you know this process? Okay? Okay, let's do example 3. Okay, now something like example 3, I know if you were making the quiz tomorrow or the unit exam, you would put something like this on there because it kind of throws a little bit of, hey, you know that when you multiply two things together, that's the same thing as area. Length times width, that's area, right? So we can do area here. We can use this. Now, they say that the area of a field is 12a squared plus 25a minus 7. Okay, so picture it. Entire area of the field is 12. We've got a field out there. If you lack the visual, it's out there. And it's 12a squared plus 25a minus 7. And it says the length is 3a plus 7. It says find the width. Okay, well, a good thing to know is the formula. Area equals length times width. Okay, so I know area. Yep. Check. I know length. Check. Okay, so I need width. So I will divide both sides by length. Area over length equals width. Okay, and then I will do that. Area is 12a squared plus 25a minus 7. What is the length? It is 3a plus 7. Okay? We're doing division of polynomials. That's what rational numbers are division. Like 3/4 means 3 divided by 4. 1/2 means 1 divided by 2. Okay? Try it in your calculator anytime. So this question, hey, that fits quite nicely what we're doing because we're dividing rational expressions. Okay? So we're now going to just factor the top because what two things add to give me 25 and multiply to give me, what is that, negative 84. Okay, so we want to look at, first of all, what would the signs be? Nope. Yes. Nope. He's right, a plus and a minus. Right, because two negatives would have been a positive 84. Okay? Okay, so this is 12a squared plus 28a minus 3a minus 7 all over 3a plus 4. Now, out of this set, I can take out a what did I do wrong? Oh, I get it. I'm looking up top going, where's my positive 7? I have a negative 7 there. Okay, so I can take out a 4, right? 4a, leaving me with 3a plus 7. It's a good thing I changed my 7 on the bottom, or I wouldn't be able to cancel anything, will I? I can take out a negative 1, leaving me with 3a plus 7. And that's all over 3a plus 7. So this goes to 3a plus 7 times 4a minus 1. That's all over 3a plus 7. Okay. Cancel, cancel. So width equals 4a minus 1. Any restrictions? A can be anything but negative 7 over 3. Okay, so B kind of depends on did you do A right? Because it says the perimeter is 54 meters. Find A now. Okay? So you can see why this is a really good question. I mean, as a teacher, it's a really good question. As a student, you're like, oh, this question sucks. But if you get it, then you're understanding this stuff. Now, again, it's always good to know what is perimeter. Well, remember, it's length, width, length, width, right? I got to add those all up. So perimeter equals 2L plus 2W. Do I know L? Yeah, I know perimeter, actually. It's 54 equals 2 times L is 3a plus 7, right from the question. Width is my answer I just got. A minus 1. Okay, so then all you have to do is go 54 equals, and I'm going to multiply this in. That's 6a plus 14. Multiply this in. That is 8a minus 2. So 54 equals 6a plus 8a is 14a plus 12. Subtract 12. Subtract 12. What am I talking? Yeah, 14a, that's right. Okay, and then subtract 12. So I'll get 42 equals 14a. And then all now you have to do is divide by 14. A equals 3. That's the value of A. Now C says, we'll find the cost to treat it with fertilizer. And it's $2.40 a square meter. Well, we know the area is 12a squared plus 25a minus 7. That's right from the question. That's the area. Okay? So all I have to do is take the area and multiply by $2.40 per square meter, because the area is going to be square meters. Okay? If only I knew A. Well, I do. For my last question. So big A's area is 12 times 3 squared plus 25 times 3 minus 7. Put that all into your calculator, area equals 176 meters squared. Now, it always is bad when a student stops here and they didn't answer the question, because they knew the math. They did a lot of good stuff to get there. They just forgot to go, you've got to multiply this by $2.40 a meter, and that gets you, if you multiply those two, that equals $422.40. Okay. Now, example 4. What's different about example 4 and all those that's never done before? 2 variables. Okay? So let's deal with 2 variables. So I got x plus y over x minus y. Okay? So this one's really sweet, right? You can cancel the x's, and then if you cancel the y's, you can leave that a negative, and then you would be just left with, let's be 1 over negative 1, which equals negative 1. Can't cancel terms, can you? But I get this a lot, this one. Okay? So this, you got to say no, can't cancel terms. You can only cancel factors. Okay? So can we take out a common factor out of x plus y? So just write it again. We're going to do it again. Can we take anything out of x plus y? If I take a negative out, then I got negative x minus y. Still not a good scenario, is it? Because now I got negative x on top. What if I take a negative out of the bottom? Oh, then I got negative x plus y, right? See how I cannot simplify that anymore. So it's done, except non-permissible values. What is x not allowed to be? X is not allowed to be y, is it? It's pretty deep, eh? Okay, now, if you're not into, because if x is y, that means 4 is 4, 4 minus 4 is 0. But for those people that are like, what? I would never get that. I'll show you how to do it algebraically. Because remember, the rule is x minus y cannot equal 0, correct? Everyone agree with that? Now I'm just going to do the algebra. I'm going to be x equals, so I will plus y, x cannot equal y. Okay? So if you're not kind of, maybe not thinking on that level, like x can equal y, okay, what does that even mean? Well, it means the two can never be the same, because if they're ever the same, it's going to equal 0. Can't divide by 0, it's undefined. Okay? But solve it algebraically, and it makes sense. Okay? Next one. What do we do? Difference of squares. Okay? So that's x plus 5y over x plus 5y times x minus 5y. Cancel, right? That is 1 over x minus 5y. The question would be now, what is the restrictions? X cannot, not negative, right? X cannot equal 5y. Remember, x minus 5y, so if you need to do it, x minus 5y cannot equal 0. Add 5y, add 5y, x cannot equal 5y. Yeah? Good. Okay. So what happened, what did I do? I was just looking at the answer, right? Up here, I also have to talk about that one. X plus 5y cannot equal 0. X cannot equal negative 5y. Okay? So the final answer would be x cannot equal plus or minus 5y. Good catch. Okay? So how's yesterday helping out today? Well, yesterday I said every step you got to go through, right? And make sure. If you just look at the final answer, it's like almost trying to catch you. Okay? So make sure we're looking through all the steps. A didn't have a bunch of steps. So you can see why these are like tricky, right? So C is actually a lot more work than it looks like. Okay, let's talk about the top. I can expand this to be 6 times x plus y times x plus y. Okay? On the bottom, I will take out a 3, which is x to the 4 minus y to the 4. What should I do next? Difference of squares. So my top is 6x plus y, x plus y, and the bottom would be 3 times x squared plus y squared, x squared minus y squared. And I got another difference of squares. Good. So 6x plus y, x plus y, all over 3 times x squared plus y squared times x minus y times x plus y. Okay, so cancel, cancel. Your final, oh, sorry, one more thing. Do you see how we have a 6 and a 3? We can't get rid of them, but we're going to divide each by 3, which would leave me with 2x plus y all over x squared plus y squared times x minus y. Okay, restrictions. Now, get in the habit of doing your restrictions kind of from the top down. I think if you do your restrictions from the bottom up, you'll just do the bottom. Okay? So, from top down, here's kind of where I've got it factored enough that I think I can do restrictions. Now, let's talk about this one. X squared plus y squared cannot equal 0. We're going to do that one first. So that means x squared cannot equal negative y squared, right? Minus y to both. And I got to solve for x, right? So I take the square root, take the square root. Can you take the square root of a negative? Okay? So this would be no restrictions on this one. And it makes sense. X squared plus y squared, the only way it could equal 0 is if x and y equaled 0. Okay? So let's do the next one here for restrictions here. So This one is x minus y cannot equal 0. I would add y to both sides to solve this one. X cannot equal y. Okay, then if I talk about this one, x plus y cannot equal 0. X cannot equal negative y. So the final answer would be 2x plus y over x minus y times x squared plus y squared. X cannot equal plus or minus y. Okay, now that would be an awesome quiz question, just to take it right off there and put it on the quiz. Yep.
Before you did the difference of squares on the x minus y plus y, there was x plus, or the x squared minus y squared. You'd be able to take that as just go back to the same as
Where? Yeah, because I further factored this one, right? And then got those. Okay. So, the assignment is 1 to 10, right? No, actually. Okay, so on the assignment you can omit 5, 9, and 10 to 13. I know, but it looks good. Looks like I took a lot off. I know. But so don't do them.